Hello, I'm John Einberger, Product Line Manager here at Makino. Today I'm going to introduce to you a new machine in our product lineup, the a500iR. This is a 5-axis horizontal machining center, and it features a fully integrated rotary table on rotary table design. We actually introduced the machine to the world at IMTS in 2024, so hopefully you had a chance to come and see it up in Chicago in September, but if not, we do have an a500iR installed here in Mason, Ohio, and would like to welcome anybody in to come and see that machine. From a target industry standpoint, the a500iR is going to fill a number of areas in the marketplace, spanning from aerospace to electronics, industrial components, and also for use in prototyping applications. From a basic spec standpoint, the machine has an x-axis of 900 millimeters, a y of 750, and a z of 800. From a rotary perspective, the b-axis has a range of 290 degrees of motion, ranging from negative 110 degrees to positive 180 degrees. And the c-axis that sits on top of b has a full 360-degree unlimited range of motion. The pallet size on the a500iR is a 500 millimeter square pallet. This pallet is unique to this machine in that it uses 4 spigots on the backside for location and clamping of the pallet onto the C-axis table. From a payload perspective, the diameter range ranges from 700 millimeters to 900 millimeters with a payload height of 600 millimeters and a payload capacity on top of the pallet of 400 kilograms. This is what the machine looks like from a range of motion perspective with a maximum payload mounted onto the machine. So a very rangy machine, a lot of motion, a lot of ability to get to pretty much any feature you can envision that's going to be mounted onto that work holding fixture inside of the machine. From a spindle perspective, these are 40 taper class spindles. So from a taper perspective, Cat 40, BT 40, or HSK A63. The standard spindle is a 14,000 RPM unit. One option is currently available in the 24,000 RPM high power unit, with another option planned for introduction a little bit later in 2025, a 20,000 RPM high speed unit. Pretty moderate from a floor space perspective to accommodate this machine. And tool magazine sizes ranging from the standard 90 tool ring all the way up to a 311 tool matrix. If you're familiar with the Makino a61NX5E that's been in our product lineup for quite a number of years, if you think about the a500iR, it's a much bigger version of that particular machine. Really what it was is brought to market to respond to a number of customer requests for something akin to the kinematics of the a61NX5E, but able to accommodate much bigger work pieces, both from a size perspective as also from a weight perspective. So if we compare the two machines, the 500iR relative to the a61NX5E, X stroke goes up by 170 millimeters, Y by 20, and Z by 120 millimeters. The work zone is considerably bigger. If you look at the two pictures on the screen right now, they're scaled at the same perspective, significantly more payload capacity on the 500iR. And also from a weight standpoint, going from 150 kilogram with the 61NX5E to 400 kilogram, a very significant increase in that weight capacity. If we think about one good example of the types of parts that would be commonly processed on a machine with the kinematics of the a500iR, wing ribs or flap tracks are really a good example. And this is where that size increase of the 500iR really pays dividends. If we think about the common wing rib, you think about the wing assembly on the fuselage of an aircraft, close to the fuselage, the wing rib is going to be the largest, and it tapers down as you extend out to the tip of the wing. So if we think about that family of parts and what kind of machine they need to fit on, given the overall size, in the past with the 61NX5E, we could only accommodate a very, very small subset of a part like a wing rib before we had to move up to a much bigger product in our portfolio, either a 630 or even an 800 millimeter pallet machine like our Mag 1. If we instead substitute in the a500iR instead of the 5E, we can accommodate a much bigger proportion of that family of wing ribs before having to transition to the bigger machine. So a lot more economical from the standpoint of processing efficiency, equipment cost, and floor space consumption. From a kinematic standpoint, as I noted early on, this is a rotary table on rotary table integrated design, meaning that instead of having kind of the common 4-axis machine where you have a B-axis with a pallet on top and a table bolted to the pallet, we eliminate 2 of those joints, and that table that normally would be bolted on top of the pallet on the B-axis, those 2 joints go away, and that table unit is integral to the top of that B-axis on the machine. From a kinematic standpoint, if we think about the movements of the machine, the linear axes are very much alike what we do on our NX series of 4-axis machines that the 500iR is strongly based on. So the column moves left to right in X, the spindle and its carrier moves up and down in Y inside of the column, and the table unit moves back and forth in Z. B-axis rides directly on the Z-axis carriage, with the C-axis then riding on top of B, center line around Z on the machine. As noted earlier, we have a variety of 40 taper class spindles available in the machine. The way we view the kinematics, always wanting to have a chassis of the machine that has the ability to fully apply the power output of the spindle, we feel that 40 taper class of spindles is really where this kinematic arrangement shines. A great combination of rigidity as well as agility and quickness of movement. If we think about this from a rigidity standpoint, we have a combination of a couple of very unique design features. Something that we use in our NX series 4-axis machines on the column side of the machine in the stepped bed column design. Very short force path from the cut interface down through that spindle, through the column and into the bed casting. So you have a high level of rigidity, a high level of X-axis responsiveness, because that column, which moves left to right for that X-axis move, has a big portion of its weight taken out and transferred instead to static weight in the form of the bed casting itself. If we use that in combination like we do with the 500iR with that integrated rotary table on table, also a very short force path on the opposite side of that cut equation, in through that table unit, into the Z-axis, into the bed casting. So when used in combination, really the ability for the machine to apply all of that power output regardless of the spindle choice made on the machine, in full utilization of the Y-axis, meaning that you can do heavy-duty machining high up in Y, not just down close to its bottommost value. Maximize rigidity, maximize productivity and metal removal rate, but also there's an upside to the user in that it minimizes perishable tooling wear and therefore perishable tooling cost. Like all the machines in the Makino HMC lineup that the 500iR is based on, we employ active thermal management on the machine. The whole idea with this is instead of allowing thermal events to happen and then attempting to compensate them out after the fact, with active thermal management, we're removing heat at the source of generation. So a combination of jacket cooling around the spindle, we take the heat of that drive motor out of the equation, core cooling of the ball screws, we take the heat of the motion of that ball screw out of the equation, as well as the heat of its drive motor, but also applying that active temperature control to the 2 rotary axes, which are both direct drive motors. Very good from the standpoint of quickness of movement, very good from the standpoint of minimization of moving components, but they are heat generators. By using the active thermal management system, we pull that heat right out of the equation, keep it from affecting the overall geometry of the machine. Upside to the user, sustained dynamic accuracy. So if you think about your whole process development cycle, that really aids in the process development, starting with a very thermally stable machine. A very small level of variability in the overall machining process is going to be due to the machine itself. If we think about how that translates to accuracy and repeatability of the platform, without scales in the linear axes, the accuracy of the machine is plus minus 2.5 microns, and the repeatability plus minus 1.5 microns. We do offer scales as an option on the linear axes, just like we do with the other NX platforms. And what it's going to get the user is basically half a micron plus minus increase in accuracy, half a micron plus minus increase in repeatability. There are industries where that half a micron either way makes a difference, but for the majority of users, the machine is very, very capable even without scales on the linear axes. Now, the two rotary axes being direct drive do come with rotary scales on them as standard. It's really the only practical way to know where that table unit is. With the capability of that overall system, coupled with the feedback that we employ, the accuracy of the rotary axes are plus or minus 3 arc seconds with repeatability of plus or minus 2 arc seconds. So thinking about the machine from the standpoint of the range of motion of the machine, particularly the B-axis, with that 290-degree range of motion, you have the ability to not only cut above the center line of the part, but below the center line of the part to do those undercuts that are going to be typical with a lot of the aerospace components, particularly if we think about components like blisks, things of that nature. But also, the machine has a very unique pallet changer system on it that takes that workpiece that's upright in the work zone, and as it does the rotary pallet change, tips it down to ease part loading. And we'll pull up a video here that will show you what that looks like. A couple of words on the spindle offerings on the machine. As I noted earlier, 14,000 RPM is a standard spindle. This is a unique machine, and it's really following along the lines of a lot of the Makino product innovation in that the base machine voltage has moved from 200 volts that's been commonly employed to 400 volts. With that in mind, the output of the spindle is quite a bit more pronounced, both from a power and also from a torque duration standpoint. As an example, the peak power in this 14,000 RPM spindle relative to the 14,000 RPM that we use on our a500, a600, a500Z, the peak power increases by 49%, with the sustained continuous power also up considerably by 36% relative to that older generation 14K. The peak torque output stays at 303 Newton meters, but instead of running from 0 to 820 RPM, it runs instead all the way up to 1165 RPM. So a broader torque band, more area under the curve, 345 RPM in this particular case of additional peak torque available to the user. From the perspective of the optional 24,000 RPM spindle, it's an 80 kilowatt, 107 horsepower spindle, and it has that max power available from 12,200 RPM all the way up to the top 24,000 RPM, with continuous available at 60 kilowatts. As noted before, the 20,000 RPM spindle is under development, and I anticipate that's going to be added to the product lineup in Q3 of 2025. We have a platform that has the ability to create a lot of chips very quickly. We need to be able to get them out of the machine. We need to have a high degree of machine reliability. So proven designs from the NX series continue to be employed in the a500iR, including the large center trough, single piece weight covers on both X-axis as well as Z-axis, multiple coolant delivery systems that aid the chip flow down into that center trough, just the ability to get those chips very quickly out of the machine. From an automation solution perspective, while not available quite yet, there's a planned introduction of a pallet changerless version of the a500iR. So take that pallet changer away that I showed you earlier, and instead replace that with a large opening door on the front of the machine. Where that would lend itself to is application with the Makino MMCR, or the robotic system that transports a workpiece on a subplate from centralized loading into the individual machine. The other area that it translates would be direct part load of parts onto a fixture that stays resident on the machine. Rounding out the discussion on the machine, a little focus on the control. The a500iR uses a Makino Pro 6 control. It's a very streamlined operation, very streamlined flow through the control, all the way from program preparation down to the end of the process where you see the machining results. User-friendly, intuitive to use. But in this 5-axis application also comes standard with a couple of items, including the Makino Super Geometric Intelligence, or SGI, that reduces the amount of act deck for a cutting path, results in a smoother surface finish and a faster cycle time, as well as standard collision safeguard that verifies that the machine is not going to hit elements of itself in the execution of the program. So that's the introduction of the Makino a500iR. This has been a very brief discussion today. I'd like to encourage you, if you have interest in the machine, contact your Makino sales rep and set up either a more detailed discussion that we can have, or even better than that, a view of the machine here at our Mason, Ohio facility. At this point, I'm going to turn it over to questions and answer those on an individual basis. Thank you.
Okay, thank you everyone for joining us to talk about the a500iR today. I do have a couple of questions that have come in that I'd like to address. The first of them, can I see an a500iR demo now? Yes, you can. We do have the machine set up here in the Mason, Ohio facility. It's in the Cincinnati regional area, and we do have demo material set up on the machine. So just contact your Makino sales rep and we'll be more than happy to show you that machine in action. Another question about what is the availability of the largest tool magazine and what size is that? That is a 311 tool unit, and that's going to be available for order in the May 2025 timeframe, and that would equate to a delivery of a machine in early 2026. Same can be said for the other larger magazines, the 133 tool and the 218 tool, going to be a little bit earlier availability, so look at that end of 2025, maybe very early in 2026 availability. All right, that's the bulk of the questions that we have today. Once again, thank you for joining us, and we'll talk with you again soon.